Hey guys, Shane Somerville here, MBCC St. John. Thought I'd run through the answers for one of these subnetting exercises that I posted on Brightspace. The first question was determine the subnet number, the first and the last IP address, the broadcast address for a host with the following address and subnet mask. So this is a host address. Okay, it's not a subnet address, it is a host within a network, and the mask is a /27. So you would need to be able to take that IP address and mask and determine what the class, the subnet address first and last host broadcast and subnet, the number of subnets, and the number of usable hosts per subnet. Okay, this is a common problem in network administration. So let's go through how to figure this out. So you had, what was it, 192.168.10.139/27. Okay, so one of the very first things you're going to want to do is to figure out this /27, what that is as a subnet mask. Right? Because we need to perform an AND to figure out where the subnet begins for this host address. So to do that, step number 1, /27 is 255.255.255, because that's 24 bits, and then there's 3 more. So let's do this. We want to convert binary to decimal. And we know these have 8 bits per octet, so 8, 16, 24, 25, 26, 27 to make the /27. The rest of the bits are off. And we convert that, that's 128 plus the 64 gives you 192 plus 32 gives you 224. Right? 224. So the next thing is to take the number directly over where the subnet mask splits between the network portion and the host portion and convert it to binary. So 139, we know that's 128. If we add 64 to 128, we would have 192, and that's too much. 128 plus 32 would be too much as well. And 16 and 128, is that going to go over 139? Yep. Plus 8, 136, and 37, 38, and 39. Okay, so 128 plus 8 gives you 136, and 3 more gives you 139. Okay, and if we perform an AND operation here, anything other than 2 1s results in a 0. We convert this number back to decimal, that's 128. Okay, so that means that the subnet address is 192.168.10.128. Okay, so that's where this subnet begins. This is a host within the 128 subnet. As far as the class, I guess I skipped that first question. The class is always decided by this very first octet. This being a 192 makes it a Class C address. The first host is always the next host after the subnet number. (129). Then there's the last host in the broadcast. To determine the last in the broadcast, we need to figure out how many usable hosts, or how many hosts are in this subnet. Okay, so we know it begins at 128, but where does it end? And where does the next subnet begin? Okay, if we want to figure out the number of subnets, to the power of n, number of hosts per subnet, to the power of n minus 2. Okay, and that minus 2, here this minus 2, that's minus 1 for the subnet number, because we can't use this on a host. This 128 can't be used on a PC, so that's minus 1 usable host. And the broadcast. The very last IP in the range is a broadcast address. It's all ones. We can't use it on a host either, and hence the minus the 2 for the number of hosts per subnet. Okay, so this subnet's power of n to the power of n here is the number of ones in the subnet, so the network portion, this section right here. Okay, how do we know that? We know because this is a Class C address. A Class C has a default subnet mask of 255, 255, 255, which means all the bits after this, right here, are borrowed. We borrowed 3 bits for the network. Okay, so we take n is the bits borrowed. For here, this 2 to the power of n is the number of host bits. Section right here. So that's the zeros that are remaining. These are host bits. Okay, so 2 to the power of n becomes 2 to the power of 3, right? Because 3 borrowed bits. 2 to the power of 3 equals 8. And you can see that there's 3. The next number is 8. Quick way to figure that out. This 2 to the power of n is 1, 2, 3, 4, 5. Minus the 2. 2 to the power of 5 is 32. Minus 2 equals 30 hosts per subnet. Okay, so if we take this number, 32, we knew that the subnet begins at 128. If we add 32 to it, it gives you 160. This is where the next subnet begins, is at 160. So we have between 128 and 159 for this subnet. The very last address being a broadcast. The one before that being the last usable host. Okay, just to complete, number of subnets, we had figured out there would be 8, and the number of hosts that are usable was 30. Okay, and that completes how to do the very first question. Okay, so let's do another one. So the same idea, you need to define the class, the subnet address, the first and last host, broadcast, and number of subnets for this address here. This one's a little bit different because this is a class B, begins at 172. So let's go through how to figure this out. So we have 172. Not sure why my pen looks like that. 172, 16, 40, 200 / 22. Okay, so very first step, convert this number to decimal. So the slash notation means that there are 22 bits that are turned on. So if I was to do that, it'd be 1, 2, 3, 4, 5, 6, 7, 8. That converts to 255. 9, 10, 11, 12, 13, 14, 15, 16. 255. 17, 18, 19, 20, 21, 22, 23, 24. Converts to 255. Whoops. That's /22. Alright. Getting ahead of myself. So 8, 16, 17, 18, 19, 20, 21, 22. Right, and there's 8 bits there. Alright, so convert this binary number to decimal. Six ones. Okay, so that means 128 plus 64 is 192 plus 32, 224 plus 16, 2, 3, 4, 240 plus 8, 248 plus 4 more, 252. 252. Oops. Okay, so this is 252. 255, 255, 252.0. Erase my work here. I could write that better too. So we still have to convert decimal back to binary again. Okay, and this time, right where the network and host portion splits, right here, and the number above it. This is where we're interested. And so we're going to do another AND operation between those two numbers. So the 252 right, and 40. 40 would be 32 and 8. And we do an AND. Again, 2 ones. That's what we're interested in. And 32 and 8. So it's 40. So the subnet number begins with 40. So we wanted to know the class, and this is a class B because it begins with 172. We wanted to know the subnet address, and that is 172.16, and we just figured out that that's 40.0. Okay, so 40.200 is an IP address in the 40 subnet. First IP address, 172.16.40.1. Okay, it's like an odometer. This clicks all the way over to 255, and then this would change to 41. This would begin at 0 again. We have a last IP, broadcast, number of subnets, and the number of hosts per subnet. Okay, so once again, to figure out the last IP in the broadcast, we need to figure out how many hosts are in this subnet. Okay, so number of subnets is to the power of n. Number of hosts per subnet to the power of n is still 2 to the power of n minus 2. We have to keep in mind that there's an entire octet here of zeros, so it's not a matter of 2 bits for hosts. It's actually 10 because we have 8 more. So we can either put 10 here, 2 to the power of 10 minus 2, or we could say 2 to the power of 2, which is these 2 hosts, times 256 for the 8 bits in the next octet, minus 2. It's actually easier, so you can do this without a calculator. Okay, so number of subnets. We had 2, and once again, the n here comes from the bits that are borrowed. A default class, or default subnet mask for class B is 255.255. So all of these bits are borrowed, which means that 1, 2, 3, 4, 5, 6. 6 bits are borrowed, all of these, for the network. So 2 to the power of 6. 1, 2, 3, 4, 5, 6, 64. 64 subnets. Each one of those subnets having a lot of hosts, so 2 to the power of 2 is 4 times 256. Times 256, that would equal 1024 minus 2, 1022 hosts per subnet. So 64 subnets, each one with 1022 usable hosts in it. Okay, so we know that this first subnet begins at 40. So to figure out where the broadcast is, it's easiest to figure out where the next subnet begins. And to do this, it's easiest to use this number right here before we multiply it by 256. And this is because the 40 that we're working with is in the third octet. This multiplication times 256 is because there's another whole octet. But we just need to know where this number ends. So if we use the 4, we know that the next subnet begins at 44. So we just take 40 and add 4 to it. If we take 1 away, it means that this subnet ends at 43. Okay? So 172.16.43.255. It's if all of the host bits were on. It's a broadcast is all ones. So that's the very last, that's the broadcast address for the subnet. The next one would be 44.0. That would begin the next subnet. So if we take one away, it's 43.254. It's the last usable host address in this subnet. And we said there are 64 subnets, each one with 1,022 hosts. Okay? Alright, so next question. Same idea, working with this address. It's once again a Class C address, which is a little easier to subnet. So let's work this out. Uh, 200.200.40.120/26. Alright, so again, first thing we want to do is convert this number, this /26, to decimal. Alright, we know /26 means that the first 24 bits are all on, which makes this 255, 255, 255. Right, that's 8, 16, and 24 bits. Okay, so we just need to figure out what this last number is. So we have 24, 25, 26. So 128 plus 64 gives us 192. So we know that this subnet is 192. We want to take the number where the subnet and host portion are split and the one directly above it, and AND them to determine the subnet number. So 120 converted back to decimal. So 128 is too much. 64 and 32. 6, 9, 96, and 16, 12, 11, and 8, 120. Okay? And we'll AND those two. Which means the only bit that's on is this here for 64. Which means that the subnet number is, let me write this out, so class, we determined that it's a Class C based on the first octet. The subnet address is 200.40.64, which means that the first IP is 200.200.40.65, and we need to know the last IP, the broadcast, number of subnets, and the usable hosts. Okay, so the last IP in the broadcast we determined by figuring out the number of hosts in the subnet. So number of subnets, 2 to the power of n, where n is the bits borrowed. Usable hosts, 2 to the power of n minus 2, one being the broadcast and the other the subnet address. Okay, So this N here, the default subnet mask, and you need to know your default masks for Class C, is 255, 255, 255, meaning that this 192 are borrowed bits, these two right here, which means that you're using 2 to the power of 2 for subnets. For the other side, you have 2 to the power of n, and that's the host bits that are remaining. This section right here. 1, 2, 3, 4, 5, 6. There are 6 of them, so it's 2 to the power of 6 minus 2. 2 to the power of 6 is 64. Minus 2, 62 usable hosts per subnet. So we have 4 subnets, each with 62 hosts. The first subnet began at 64. Okay, so we have plus the number of hosts before we removed 1 for the broadcast and 1 for the subnet number. So 64 plus 64 gives us 128. Take 1 away from that, gives you your end of the current subnet, this one right here. And so we know it ends at 127 with the broadcast. So 200, 240, 127. And the last IP being 200.200.40.126. Okay. And there's one more. This one, okay, so this is a Class A, begins with 10, using a /15. Okay, so we have 10.200.40.120/15. Okay, so we always want to convert the slash notation to decimal. Okay, so the first, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that is the subnet mask written out in binary. We know this converts to 255. These are obviously zeros. So we just need to figure out what this is. One, 2, 3, 4, 5, 6, 7. Now, if they were all on, it would be 255. So we take one away. Must be 254. So the subnet mask is 255, 254, 0, 0. Whoops. Now, just like before, we want to take the subnet where the network and the host portion are split and the number directly above it. And we AND those two. Okay, so 200. 128 and 64 is 192. And 8 more give you 200. We AND them. And it turns out that it's still 200. So 200 is your subnet number. So we already determined the class as Class A based on the first octet. the subnet address is 10.200, and the rest of them are zeros. The first IP will be 10.200.0.1. And it's the last broadcast number of subnets and number of usable hosts. Okay, so we want to do 2 to the power of n, figure out the number of subnets, and the hosts per subnet, it's still 2 to the power of n minus 2, where n is the number of host bits. Okay, so 2 to the power of n. First, for the subnets, once again we need to know what the default mask is for class A, and that's 255.0.0.0. So that means that all of these bits are borrowed, which is what we have here. And there are a total of 1, 2, 3, 4, 5, 6, 7 of them, which means that we use 2 to the power of 7 for the number of subnets. 2 to the power of 7 would be 128. So we have 128 subnets. Now each one of those subnets has a number of hosts. Now for the hosts, 2 to the power of n will be this bit here, but also the next entire octet, meaning this here, which has 8 bits, and 8 more. So we have the 1 plus all of the remaining host bits that can each result in a unique number. Right? So 8 and 8 is 16, and 1 is 17. So 2 to the power of 17 minus 2. Now that's hard to do in your head, 2 to the power of 17. It's a little tricky. So what you can do instead is say 2 to the power of 1, right, which is easy, it's just 2. Multiply that by the number of possibilities here in this octet. It's just 256. Could be all zeros to all ones. And multiply that number again by the final octet, which is another 256 possibilities. And then finally minus 2. So give you the same result. Okay, but we don't, unless you want to know the total number of usable hosts, you don't actually need to figure that out to figure out what the last address is. I'll show you what I mean. So 10.200.0.1, right? We know that this is where the subnet is split. We know that 2 to the power of 1 is 2. So if we take 200 and add 2 to it, it's 202 minus 1, 201. So these subnets run from 200 to 201 in the second octet, which means that the broadcast would be 10.201.255, all ones, to 255. That would be the broadcast address. One short of that would be 10.201.255.254. That's the last usable host. And we haven't figured out what the total number of hosts per subnet is yet. To do that, I'm just going to bring up a calculator. And that's 2 times 256 times 256. Big number, minus 2, 131,000. 131,070 hosts per subnet. 2 to the power of 17. 2 to the power of 17 gives you 131,072, same as what we had before. Minus 2, 131,070. So this, whether you do it this way or you write it out, you will result in the same number. 131,070 hosts, that's a lot. That's a big broadcast domain. Okay, and that completes the last question in that assignment. Thanks for watching.